All right, this is it, everyone. This is our last day of class. We are actually going to start our trigonometry supplement today, and we'll be able to finish that today. And that's it. Then the course is over. There is one bonus opportunity that I would like to give to you, and that is on page 19 of our notes. What I'd like to do with this bonus opportunity is make sure we're using the same variables. So that way, when I go ahead and I look at your work, it's like super easy for me because it's all there. So what I want you to do is turn to page 19 of your guided notes, page 19, and you'll see use linear systems in 3 variables to solve applications. You're probably thinking, but we skipped like 5 pages. Yeah, we skipped all of the pages pertaining to 098. When I teach this course again, those problems are going away. We're not going to redo what we did in 098. That makes no sense to me. And actually, there's a lot of content in this course that I'm going to be like, gone. So having said that, let's take a look at the problem on page 19. And I just want you to use the same variables that I'm going to use. Okay, so let me show you, and then we'll move into trigonometry. As a reminder, this is a bonus problem. So this is worth 2 test points, which is actually pretty huge, because your tests are not out of 100, they're out of like a raw score, right? Sometimes it's out of 35, sometimes it's out of 25. So imagine getting 2 points. It's a huge boost to your grade. We're told a 141 person cruise on a submarine. The number of chief petty officers is 4 more than the number of commissioned officers. The number of other enlisted men is 3 less than 8 times the number of commissioned officers. Determine the number of commissioned officers, which we will call C, the number of commissioned officers. We also have to find the number of chief petty officers, which we will call capital P. And we also want to find the number of other enlisted people. So I'm going to call E, number of other enlisted people. Good. If you're using those same variables, then you'll go ahead and construct your system of equations, and you will use the techniques that we have learned so far to solve. Please make sure you use CPE. Yes, this is on page 19. This is page 19. Excellent. So CPE, I'll give you a moment to make sure that you're writing these variables down. This is what I'm looking for. Please don't use any other variables other than C for commissioned officers, P for the petty officers, and E for enlisted people. Now, when to turn this in? Anytime before our final deadline. Shane, I'm not answering that. I'm not answering that. I don't know. So these will be due the last day that your other homework assignments are also due, which is Saturday by midnight. Okay, so you have some extra time. Make sure you get all your work done, okay? Because otherwise, what was the point? That's all I gotta say. As a reminder, if you need any help from now until Saturday, just shoot me an email. I'm here. I'm literally here. So if you have any questions, you're like, I'm stuck. Is there any way you have a couple minutes just to look at something with me? I can do that. My advice to you is when you send me a problem that you're looking at and you're stuck on, show me the work. I don't want to see a question and have no like frame of reference. Like you've got to tell me what you're trying, what you're doing. Even if it's an actual picture of your work, that'll help immensely, because then I can troubleshoot and be like, oh, here it is, this one tiny little thing that changed all of that changed your answers. So be sure to communicate. These last few days are incredibly crucial, and I want you all to do really well. But the only way I can help you is if you reach out and communicate with me. All right, deal? Cool. Let's finish our notes. let's look at trigonometry. Dun, 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 dun. What's the sum of the measures of the angles in any triangle? How many degrees?
180?
Yeah, score. Always 180, right? It doesn't even matter like if it's acute or obtuse, equiangular, isosceles, it doesn't matter. The sum of the measures of the angles will always be 180. The labeling convention, you typically label sides with a lowercase letter and you label angles with an uppercase letter. That's pretty typical. When you see this in like math text or anything like that, little baby lowercase letters are the sides. Okay, we are going to label the hypotenuse for our triangle, and then we want to label the sides that are opposite and adjacent to angle A. Now, here's the deal, everyone. When we think about understanding trigonometric ratios, it really depends on the angle from which you are working. Okay, so in this case, we're asking you to work from angle A, right? So from that position, in that particular spot, you then have to say, well, which side is adjacent, which side is opposite, and as always, which side represents your hypotenuse. The good thing about the hypotenuse is that it doesn't matter where you are in your triangle, the hypotenuse will always be the hypotenuse. But in terms of adjacent or opposite, that's different. It depends on your location. So let me show you what I mean. So we're being asked to essentially use angle A as our viewpoint, right? No matter what, remember everyone that the side opposite the 90-degree angle, you see how this side is opposite this 90-degree angle? This will represent our hypotenuse, no matter what. And if it helps, you can even draw an arrow that shows that this side is opposite the 90-degree angle, so it has to be the hypotenuse. Now, because our reference is here at angle A, we have to think, well, which sides are opposite and adjacent? I already took care of our hypotenuse, right? We need to figure out if I'm at angle A, which side is opposite? And if I'm at angle A, which side is adjacent? Adjacent obviously means right next to, and opposite, you know what opposite means. So when you're standing here, and I'm going to draw a stick figure, you know, don't like be upset with me for that. I'm going to draw my little person right here. So if my little person is standing right here, it's reasonable to say that if this is the hypotenuse, then the side right next to this little person is adjacent because it's right next to them. And then way across the way is the opposite side. It's as simple as that. I want you to think, obviously, right next to that angle has to be adjacent. We know which side is hypotenuse always. And then all the way across the hall is opposite. Let's do it again, except for this angle, for this triangle, you're here at angle A again, but that's this bottom right-hand corner. Go ahead and label your hypotenuse, your opposite side, and your adjacent. We're here at angle A. Go ahead and label that, just take 10 seconds. Hypotenuse, label that first, then decide which side is adjacent, which side is opposite. Okay. So the side opposite the 90-degree angle, that's always our hypotenuse. We can always label that first. So it's the side opposite the 90-degree angle. And again, if you'd like, I can just draw a dotted line to show you. Next, this side right next to angle A must be adjacent, right? That's what that word means. So it's got to be. And then all the way across, that's our opposite side. All right. If you have any questions, stop me. But did that go well? We okay with that so far?
Professor, can you just scoot the page up to the first part real quick?
Yeah, for sure.
Thank you.
Right here. So here we just filled in that the sum of the measures is 180, but then we just noted that the sides are typically lowercase and the angles are typically uppercase.
Okay, thank you.
You're welcome. Perfect. All right, let's turn the page. Hopefully the positioning is totally cool. We know which side is the hypotenuse, and then you just have to figure out what's next to you and what's opposite. Okay, let's go ahead and turn the page. A high-flying kite is attached to a 1,300-foot string, as indicated in the accompanying diagram. So here's a string, and it's stuck here in the ground. What is the measure of angle C? Let's start here. Go ahead and shout it out. What's the measure of angle C? Only one person takes it, and then we'll keep switching from there. Zach. Oh, no, I can't hear you. Ooh, as something's going on with your sound, I still can't hear you. Can someone help?
90.
90,
Yeah.
yes. Good. So we know this angle is 90 degrees. So that means that this side of my triangle has to be the hypotenuse. It might not be a bad idea just to label that, right? Why not? Good. Thank you. Someone else, what's the measure of angle B? And how would you find that? Talk me through finding angle B. Go ahead and take this.
5 degrees.
And how'd you get that?
Okay. Sorry, I added angles C and A and subtracted that from 180.
All right, so C and A, so 90 degrees and 39.5. And then we subtract that from 180. Don't worry about the negative, I just subtracted it, but I know it's going to be a positive, just like Shane said, 50.5 degrees. So 50.5 degrees. Very nice. Thank you, Shane. Someone else, what is the length of the hypotenuse? Shout it out.
1,300.
Yeah, 1,300. Was that Jimmy?
Yeah.
Perfect. Thank you, Jimmy. 1,300 feet. Very nice. Someone else, what is the length of this side opposite angle A?
Oh.
Say it louder.
50.
Ooh, I think that's
500 feet.
500. Good. 500 feet.
Cut off.
Yeah, I figured. So 500 feet, this is the side opposite angle A. Very nice. Someone else, what is the length of the side adjacent to angle A? And thank you, James, for answering.
1,200.
Yes, 1,200 feet. What is the length of the side opposite angle B? Someone else?
1,200 feet.
Yes, 1,200 feet. Very nice. And last one, what is the length of the side adjacent to angle B?
1,300.
Ooh, are you sure?
500 feet.
Yes, 500 feet. Very nice. The reason it's not going to be 1,300 is because 1,300 represents our hypotenuse. So once one of your sides of your triangle represents the hypotenuse, it will never actually be adjacent or opposite. It can't be. So we have our hypotenuse, which means pertaining to whichever angle you're standing next to, you're either looking at your adjacent side or your opposite side. From here, adjacent, and then opposite. Very nice. In any triangle, the shortest side is opposite the smallest angle. That's something really, really important to know, and it'll always actually be the case. Therefore, the longest side is opposite the largest angle, which is why the largest angle, which is 90 degrees in a right triangle, it points to the longest side. Okay? We are now ready to talk about our trigonometric ratios. So we have SOHCAHTOA. Has anyone heard of SOHCAHTOA? Some old horse caught another horse, taking oats away.
I haven't heard that,
Yes,
like,
unfortunately.
and
Some old hippie caught another hippie tripping on acid. Yeah, another one. Is that crazy? Sorry, I've heard that. I heard that. So we have our 3 trigonometric ratios. What I like is what's written in here. So I want your eyes to be really focused on these 3 equations because they're written in the way that you're supposed to write them. So essentially what this says is that sine of angle A you can find this measure by taking the length of this side opposite A and dividing that by the length of the hypotenuse. So sine opposite over hypotenuse. For cosine of A, you can find that by taking the length of the side adjacent to A and dividing by the hypotenuse. Cosine adjacent over hypotenuse. For your tangent, if you have the tangent of A, you can find that by taking the length of the side opposite A and dividing by adjacent to A. So TOA, right? So got TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Keep in mind that trigonometric ratios are defined for a specific angle, right? So essentially you're saying sine of an angle A. Sometimes we will have the lengths and other times we'll have the angle. So we will have one of the three pieces of information and we just need to solve for the third, right? So I'm sorry, I said that wrong. Let me try that again. Wake up, brain. In any of these equations, you have three unknowns. All I need to do is give you two of them so that you can solve for the third. The quote unquote trickiest part is solving for the angle itself. But when I show you exactly how easy it is, you can be like, oh, okay, that's not a big deal. Note that sine, cosine, and tangent can never be written without an angle, which is why I want your eyes to be focused on this: sine of an angle, cosine of an angle, tangent of an angle. And then the side lengths, they have to be measured in the same units. But this has always been consistent across the board. You're never going to have a diagram that has like meters and then feet. And if it does, you need to make sure they're the same units. I'm not going to do that to you in this class, so don't worry about looking for me trying to play around and trick you. I'm not going to do that. All right, so let's start by calculating the three trigonometric ratios for each of these, okay? So let's look at our triangle, this first one. Notice the orientation. Notice that I want to find sine of A, cos of A, tangent of A. So let's go ahead and draw this little angle curve here, this arc here, just to identify I'm here. You could also draw your little stick figure if you'd like. It doesn't matter. These are your notes. You do whatever your heart desires. The first thing I'm going to do is I'm going to label my hypotenuse. And then because I'm here at angle A, which side is opposite? The 3 or the 4?
3.
Yeah, the 3 and 4. Which means adjacent is the 4. Ooh, I smudged that. Cool. So when you think of sine, S-O-H, so opposite over hypotenuse. When you think of cosine, ka, A over H. And when you think of tangent, toa, O over A. Opposite over adjacent. So now we just fill in the blanks. So sine of A is equal to opposite over hypotenuse. So sine of A, the exact value is 3 over 5. That's literally all we're doing. Cool, right? With cosine, we simply say cosine of A is adjacent over hypotenuse. That's 4 over 5. And the tangent of A is opposite over adjacent. So that's got to be 3 over 4. Score. And you're done. That's it. You found the exact values for the three trigonometric ratios for angle A. Let's do it again. Go ahead and work on this problem. I'm just going to give you 60 seconds. Write out your trigonometric ratios for sine of A, cos of A, tangent of A. You're here. Go ahead and write out your ratios. Just take a minute. Don't overthink it. It may help if you label the side that's hypotenuse, the side that's opposite, the side that's adjacent, and then write your ratios. Okay, very nice. Let's start with Tiana. What's the sign of A? What did you write for the sign of A?
2 over square root 13.
Love it. In my, excuse me, I almost said my math lab. In Lumen, this will be accepted. Okay. And actually for this course, even on the final exam, because the final exam is in Lumen, this will be accepted as well. But typically you're not supposed to leave your answer with the square root in the denominator. So really this should be fixed. This is the correct ratio, but let's rationalize it by multiplying by square root of 13 so that our actual answer is 2 square roots of 13 over 13. Very nice. Didier, cosine of A. What is that one?
Three square roots 13 over 13.
Yes, thank you. And no worries, Didier, he's got you covered. So let me show you exactly what happens. We have adjacent over hypotenuse. That's 3 over
Oh,
square.
I apologize. I didn't realize that was someone's name. I didn't understand what you said. I apologize.
That's okay, no sweat. So it is true, we have 3 square roots of 13 over 13 because we did have to rationalize that. Very nice. Jose, what about the tangent of A? What did you get for the tangent of A, Jose?
That will be 3 over 2.
Ooh, switch them. 2
2
over,
over 3.
yeah, because remember, we want the side opposite over adjacent. So that's the side opposite, and that one is adjacent. So again, to help kind of start the process, make sure you label all your sides. So this side across the way, this is my opposite side. And then here is adjacent, and I'm gonna squeeze that in there. Very nice. And then luckily 2 over 3, we don't have to do anything with it. It's simplified all the way. All right. Go ahead and write out the ratios for both of these problems. For sine of B, cosine of B, tangent of B. For both of these. Again, it's going to help if you label your 3 sides. What's a hypotenuse, what's opposite, what's adjacent, and then go ahead and fill those in. As you're working through this, notice that the triangles are identical. The only thing is our position has changed. We're looking at this from angle B instead of angle A, which does change the ratios. But what it won't change are the values of the angles, which are really, really cool. So for instance, each of these ratios will give you the same exact measurement for angle B if we were to solve. Great question. Excellent. When you're done, would you be so kind as to type done in the chat, just so that I know? Thank you, Shane. Thank you, Phil. Thank you, Tiana. All right, let's check this out. Label your hypotenuse in each case. So I'm going to do that. That is going to help. Another thing that may help you all is figuring out that if your angle is B and this side is a hypotenuse, then the other side that makes angle B has to be adjacent. It makes angle B. So angle B is created by taking this line segment AB and connecting it to line segment BC. So if AB is your hypotenuse, that must mean BC is adjacent. That's another way to think about that. Where the side opposite angle B, here's the side opposite angle B, is exactly that, opposite. With our second one, notice that angle B is made from A, B, and then BC. AB is your hypotenuse, and BC must then be adjacent, which means the side all the way across has to be opposite. For your sine of B, opposite over hypotenuse, you should have had 4/5. For cosine of B, adjacent over hypotenuse, that should be 3/5. And then for tangent, it's opposite over adjacent, which is 4/3. And that takes care of your first set of trigonometric ratios. For your second triangle, we want sine of B, which is opposite over hypotenuse. So that's going to be 3 over the square root of 13. When we clean this up, we get 3 square roots of 13 over 13. Cosine of B is going to be adjacent over hypotenuse. Notice the similarities between this example and the one directly above it. And then finally, we want tangent of B, which is opposite over adjacent, that TOA. So that's going to be 3/2. Any questions on this page as we move forward?
It's just like the opposites and the adjacent sides, they confuse me.
Keep
What?
this in mind. Whichever angle you're starting from, draw a line that connects the two that make the angle. If you do that, and you say, these are the lines that make my angle here, then you already labeled your hypotenuse. So then you say, oh, this one has to be adjacent because it's right next to it. It creates my angle. And then if you draw your lines like this, doesn't it look like it's kind of like opening up, like you're yelling at this side? Like it's almost like you can shout across the way to this side. So this would represent your opposite side. It's all the way across the way. Does it kind of help to think of it like that?
Yeah, okay, thank you.
Sure. Very, very nice. You're welcome. Cool. All right. We know how to use the Pythagorean theorem, so we're just going to do this once. As a recap, we know that C is our hypotenuse, that's the longest side. So as long as we label our hypotenuse C, it really doesn't matter what we label A or B. It's really interchangeable. So I'm just going to call this A and I'm going to call that B. You can only use the Pythagorean theorem when you have a right triangle, and you'll use the Pythagorean theorem when you're missing one of your sides. We've seen this in an earlier unit when we were looking at algebraic expressions. So these are exceptionally tame compared to that. We had to do some crazy stuff when we were using the Pythagorean theorem before. So for each triangle below, we want to calculate the 3 trigonometric ratios for sine of A, cosine of A, and tangent of A. We still want to do the exact same thing. The only issue here is that we're missing one of our sides. So because we're missing one of our sides, I'm going to note that this is C, right? That's my hypotenuse. We can even write that out if it helps. And we're just going to call this one lowercase a, and then we'll call this one B. And we just have to figure out what A is before we can answer the trig ratios for sine of A, cos A, tangent of A. Let's use our Pythagorean theorem. Would someone give me the equation that we're going to use in this case?
A squared plus B squared equals C squared.
And now fill that in. With our,
A squared plus 5 squared equals 9 squared.
yeah, exactly. A squared plus 5 squared equals 9 squared. Let's go through the motions here. 5 squared is 25, 9 squared is 81. Subtract 25. We get 81 minus 25 is 56. So we have A is equal to the square root of 56. If you're wondering why I didn't write plus or minus, we cannot have negative length. So even though I did take the square root property, I'm not going to write plus or minus because we can't have a negative length. The next thing I'm going to do is I'm going to simplify this. 56 actually breaks down into 4 can go into 56. That's a perfect square. So this breaks down into 4 times 14, where square root of 4 is 2. So 2 squared to 14 is my length A. So I'm just going to fill that in, 2 squared to 14. Now, Jimmy, we want to find the trig ratios for sine of A, cos of A, tangent of A. So I'm here at this angle. Jimmy, out of the 2 squared to 14 or the 5, which one is adjacent?
Would it be this, the 5?
Yes, it would be perfect. So let me label this adjacent. We already have
One would be the
hypotenuse.
opposite, right?
Yeah, this one would be the opposite.
Okay, awesome.
Yes, I love it. Very nice. So sine of A. Kim, would you give me sine of A? What's the trig ratio for that one?
2 roots of 14 over 9.
Yeah, perfect. The cool thing is we don't even have to reduce that. Nothing reduces here, so we're done. Thank you, Kim. That was perfect. Phil, what's the cosine of A?
2 square roots of 14 over 9.
Ooh, careful. Cosine is that ka. So adjacent over hypotenuse.
Oh, I'm looking at the wrong, because I was doing the Pythagorean theorem. I had it labeled A.
Ooh, okay, okay.
5 over 9.
Yes, perfect. And then we want tangent of A. James Wilson, what is the tangent of A in this case?
I'm uncertain.
Okay, okay. Would somebody back him up? Tangent of A is
Two
OA, that's
14 over
TOA.
9.
What is it?
It's the 2 squared root of 14 over 5.
Yes. So think of the trigonometric ratio, this idea. Actually, it might help to write it this way. Can you write this down in your notes? So
Yeah, I was just about to say I usually write Silicatoa so I can remember how they go whenever I do them.
actually, I do too. I still do. I always write it down. And then I can say, oh, opposite over adjacent. So then opposite is 2 squared to 14. Adjacent is 5. So 2 squared to 14 over 5. We can't reduce here, so we're actually done. Good. Good. Let's try part B. Go ahead and do part B on your own. You have sides 7 and 11. We're missing our third side. Let's find that one first. Think about the position that that side is actually in. I'm going to pause the video. When you're done, go ahead and say done. We want to start by using the Pythagorean theorem. We have 7 squared plus 11 squared is equal to c squared. 49 plus 121 is equal to c squared. We get 170 is equal to c squared. Now let's take the square root of both sides. Square root of 170 is actually not able to be simplified. So we're simply going to replace c with the square root of 170. I now want to find the sine of A cos A tangent of A. So we're here at this angle. which means that my side C is hypotenuse, is the hypotenuse, if I'm going to talk. And then because this side also makes angle A, it must also be adjacent. And the side opposite is our 7. So let's fill in the blanks. Sine of A is opposite over hypotenuse. That's going to be 7 over square root of 170. We clean this up by rationalizing. And that leaves us with 7 square root of 170 over 170. Okay, perfect. By the way, on your homework assignments or your test, if you do rationalize your answer and it gives it to you and it marks it wrong, just tell me. I'll give you the points right back. I would much rather you rationalize your answers than not. Cosine of A is adjacent over hypotenuse, so 11 over square root of 170. Rationalize it, of course. And our final answer is 11 times the square root of 170 over 170. And then we want the tangent of A, which is opposite over adjacent. So that's going to be 7 over 11. And you're done. All right. As always, if you have any questions, don't hesitate to ask. That's what I'm here for. And don't feel like you can't because, oh no, you know, maybe other people are getting it and I'm not. So I don't want to ask. Don't feel that way. Okay. Turn the page when you're ready. Okay. We have yet another example. It would be worthwhile taking a look at this one because one of our sides is already a square root, but that shouldn't freak you out at all. We still need to find the missing side for our triangle. So we're still going to use the Pythagorean theorem. We have 3 squared plus b squared is equal to square root of 15 squared. Okay, I just want to show you what the setup actually looks like. So if we go through, we get 9 plus b squared is equal to square root of 15 squared is 15, right? We know this. We'll go ahead and subtract 9. That gives us b squared is equal to 6. Take the square root of both sides and we find that b is equal to the square root of 6, which does not simplify. Okay, and then we could find sine of A, cos of A, tangent of A. Someone, what is my sine of A before you rationalize? What is sine of A?
Three over square root of 15.
Love it. So right off the bat, what Phil is identifying is that my side across the way, this has got to be opposite. My square root of 15, that's definitely hypotenuse, which means my square root of 6 is adjacent. Very nice. So we rationalize this pretty quickly. And we have 3 square roots of 15 over 15. But what do you notice? 3 square roots of 15 over 15, what can we do? Would you leave your answer like this or no?
You can reduce it.
You can. You can reduce that 3 and the 15. So sine of A actually reduces. Remember, 3 goes into itself once and into 15 5 times. So this becomes square root of 15 over 5. If you want, you could put a 1 in front. That's totally up to you. So in this case, we actually went a little bit further because we were able to. Very nice. So someone else, so Phil gave us sine of A. Would someone else give us cosine of A? Again, without rationalizing, just as is initially. What's cos of A?
So it'll be O over H. So
Or you mean A over H? Ka?
yeah, sorry.
That's okay.
Over H. So B. So the first one would be B square root of 6. And then the second one would be square root of 15.
Yes, love it. Square root of 6 over square root of 15. We learned that the fraction of square roots is the same as the square root of a fraction. So I'm actually going to reduce here. I can divide both of these by a 3. So that's the first thing I'm going to do. So dividing both by a 3 leaves me the square root of 2 over square root of 5, right? But we have to rationalize. We're not going to leave a square root in our denominator. So now I multiply by the square root of 5. When I do so, my final result becomes square root of 10 over 5. And that is simplified all the way. We know that there's no coefficient other than 1 in front of square root of 10, so I can't reduce any further. Good. And lastly, we want tangent. So Phil gave us sine, Jimmy gave us cosine, someone else, what is tangent of A?
Three over 6.
3 over square root of 6. Yep, that's correct. And of course, let's rationalize. So multiply by the square root of 6. And then we see, aha, I can reduce here. So 3 over 6 reduces to 1 over 2. So tangent of A is square root of 6 over 2. And now we're done. Very cool. Does anyone have any questions for me on this process? I'm glad we actually looked at part C because there was more involvement for this kind of a problem. Okay, hearing no questions, take a look at example 24. With example 24, we're given the first trig ratio, sine of A is equal to 3 over 4. What we're looking for is, well, then what's cos of A and what's tangent of A, right? Now, interestingly enough, for this particular problem, we weren't given a diagram. We were just told that sine of A is 3 over 4. I think you're already uncovering the process that you want to take because we know that, and again, let's write the ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're told that sine of A is 3 over 4, which means that the 3 is opposite and the 4 is the hypotenuse. So let me draw a little triangle. Okay. We know that the 4 is the hypotenuse. So I'm going to label that here. And we know that 3 is opposite. So I'm going to put angle A here, which means 3 is opposite. So what we're missing is our third side, which we need to find in order to be able to write out the trig ratios for cosine of A and tangent of A. A diagram is always going to help, so I highly recommend that whenever you see these kinds of problems, you go ahead and draw it and you label it so that everything is super clear. We want to find the third side, so we have 3 squared plus b squared is equal to 4 squared. 9 plus b squared is equal to 16. Subtract the 9, so b squared is equal to 7. So b is equal to the square root of 7. So I'm going to go ahead and label that here. And now we're ready to write out our other ratios, cosine of A and tangent of A. Cosine of A is adjacent over hypotenuse. So we have square root of 7 over 4. You won't go further with that. We don't have a square root in the denominator, so we broke no rules. Nothing can be simplified, so we're golden. Tangent of A is opposite over adjacent. Opposite side is 3, adjacent is square root of 7. Now we have to rationalize. And so we're left with 3 squared is 7 over 7. And now we're done. Look at part B. Tangent of B is 4. What's that telling you? I'm going to draw a triangle. Help me fill this triangle in. What's happening here?
Whatever the value of b is, it's going to be -4 in the end. Or,
Well, how about this? We know that tangent is opposite over adjacent. But this says tangent of B is 4. How can I rewrite this so that I have information about the opposite side and the adjacent side? What can I do with that 4? Isn't it supposed to be a fraction?
4/1.
Yes, there we go. 4/1, beautiful. So we have tangent of B is 4/1. So we know that the 4 is opposite and the 1 is adjacent. And it doesn't matter where we put B. I'm just going to go ahead and place B at this angle. The opposite side is 4 and the adjacent side is 1, which means what we don't know is the hypotenuse, which is our C in this case. And then we can go through the motions of solving. Very, very nice. Very nice. Sometimes you got to get a little creative with this kind of thing and being able to see, well, oh, okay, I know that every whole number can be expressed over a 1, so let's write it out that way. So we have 4 squared plus 1 squared is equal to C squared. 16 plus 1 is equal to C squared. And then we see that C is square root of 17. We have tangent of B, but they also want sine of B and cosine of B. Very cool. Would someone give me sine of B?
Four over root 17.
Yeah. 4 over square root of 17. We're going to rationalize this. So we have 4 square root of 17 over 17. Good. I also would like cosine of B. Someone else? So someone other than Shane for cosine of B. What do you get?
1/17.
Yeah, 1 over square root of 17. Very nice. And then we'll just clean this up by multiplying by the square root of 17 over square root of 17. And we get square root of 17 over 17. And now we're done. Excellent, excellent, excellent work. So this is what it looks like if you're given an actual trig ratio, but you need to find the other two and you're not provided with a diagram. So I would, again, recommend draw the diagram, label the sides so that it's super clear. Beautiful. So what I hinted at earlier was that for each of your trig ratios, it has 3 components, right? So for instance, if you think back to sine of A, you had sine of A is equal to opposite side over hypotenuse. So if I gave you 2 of the 3, mathematically, you can find the missing piece. You can find that third piece in that equation. What we're about to do right now is prove that you can actually do this mathematically. I want you to think back to all of your algebraic skills that you have learned so far and use that in solving for the missing piece. So let's take a look at this example. We have cosine of 72 degrees is equal to 5 over x. I want to solve for x, right? What might be the first thing I can do to help me solve for x? What should I do initially? Give me an idea.
I mean, you want to label everything and
Oh, like opposite, adjacent.
yeah,
Typically, we would do that if we were actually given both of these values, because then you would say, okay, what I'm missing is the third side, right? For instance, if you wanted the other ratios. But I want you to put the triangle away just for a second and instead tell me, how do I solve just for this x? Mathematically, how do I solve for x? What should I do first?
Multiply by 5.
Now, if I multiply by 5, I just want to show you what happens. And I'm doing this in pencil, so don't write this out. If I multiply both sides by 5, check this out. Then I have 5 times cosine of 72 is equal to 25 over x. Shoot, by multiplying by 5, it doesn't help me move x or, help me solve for x. So let's go back to the drawing board. Give me a different perspective. What else could I do? What am I actually dividing by?
Multiply by x.
Yes, there we go. I'm actually dividing by x. This says cosine of 72 degrees is equal to 5 divided by x. So what if I say, okay, let's multiply both sides by x. If I multiply both sides by x, I have x times cosine of 72 degrees is equal to, and then the x's cancel, and it leaves me with 5. That's actually pretty cool. And now I have one last thing that I need to do in order to get x completely by itself.
Divide the cosine.
Yeah, exactly. You're exactly correct. And we can now divide both sides by cosine of 72 degrees. This takes us right back to those rational equations, right? So we divide both sides by cosine of 72. And then please take your calculators and let's type in 5 divided by cosine of 72 degrees. And there you have it. You've just solved for x.
Nice.
Typically,
Mhm.
oh yeah, go for it.
No, I just said nice.
It is.
Yeah.
It actually really is. Typically for these kinds of problems, you'll be asked to round to a certain place, which is great because you can just type it in. So if we round it to the nearest tenths, we'll say 16.2. And that would be our solution. What I want to show you is something really, really interesting. Our original equation was cosine of 72 is equal to 5 over x. When I multiplied both sides by x and then I brought the cosine of 72 over, do you see how all of a sudden our new equation was x is equal to 5 over cosine of 72, right? Look at where we were. Cosine of 72 is equal to 5 over x, and look at where we ended up. X is equal to 5 over cosine of 72. The reason I wanted you to look at these is because what do you know? All you did was switch the x and the cosine of 72. You switched places. Because this is a proportion, you're allowed to do that. You're allowed to switch your means or your extremes, right? So we can actually take the cosine of 72 and x and flip places. And it would be the exact same equation, which is nuts to think, but we proved that mathematically. We multiplied by x, then we divided by cosine of 72. So this is just a tiny little shortcut that I liked when I was first learning this. And you only need that when you have your unknown in your denominator. That's the only time you ever need this. You could say, oh, let's just switch these two. If we switch these two, then I can solve, right? Like for instance, look at our second one. It makes no sense to switch a 3 and a sine of 12 because that's not going to help us solve for y. For our second example, what we're going to want to do is use the LCD or recognize that this is sine of 12 degrees equals y divided by 3. So naturally, we'll want to multiply by 3. The great thing about this is that we know that 3 times sine of 12 degrees is equal to y. So all I have to do is punch that in. I actually don't have to do anything further other than punch that in. So 3 times sine of 12 degrees. And there you have 0.623, etc. So we're just going to say 0.6 is equal to y. And you're done. So there's always a place for certain strategies. And if that idea of just flipping them threw you off, then just go through the math. Go through the math that you're familiar with, multiply by the LCD, divide by the quantity that is attached to your variable so that you can solve for that variable. Very cool. Let's get into some fun stuff. Now we're going to actually use, our trigonometric ratios. So given a right triangle, triangle ABC, having side C as the hypotenuse, answer the following. Give answers to the nearest 10th. We're told that angle A is 36 degrees and the hypotenuse C is 96 yards. I'm immediately going to label that. We want to find the length of side B. Now, you're probably going to be really annoyed by this, but you were told that C is the hypotenuse, right? Which means the side opposite A has to be little lowercase a. If this represents C and points to side C, then here's angle B and it points to side B. I want to label that for you. Here's triangle ABC where C is the hypotenuse. That must mean that capital C has to be the 90-degree angle.
So you're just labeling the angles and sides.
Yes. Yep. And your capital angle always points to the lowercase angle. Capital B, lowercase b, capital C, lowercase c. Sweet. So we want to find the length of side B. So here's what we do. We're going to use trigonometry to do this. The first thing we need to recognize is that we're given angle A, which is 36. So what's going to help us is to label all the sides, opposite, adjacent, hypotenuse. Take 5 seconds. Write down which side is a hypotenuse. Remember, we're here at angle A. Write down which side is opposite and write down which side is adjacent. Take 10 seconds to fill that in. Hypotenuse, opposite, adjacent. Where are they? Cool. Keep in mind, it doesn't really matter if we're using A or B. I'm just going to use A because that was given. So hypotenuse is definitely our 96 yards. Because we're here at angle A, little lowercase a is going to be opposite, and B, lowercase b, is going to be adjacent. Very nice. We are asked to find the length of side B. Side B is adjacent. The only other piece of information we were given is the hypotenuse. So if I have to find adjacent and I was given hypotenuse, which trig ratio would you be using? Which trig ratio deals with these two? Adjacent and hypotenuse.
Cos?
Yes, cosine, perfect. Again, just like Jimmy had suggested earlier, let's write out those ratios just so that we have them. So, ka, toa. It's going to be really helpful to see that. Pretty much on every page. So we need to find B. We know that's adjacent. We have the hypotenuse, so that must be cosine. Let's write the equation. Cosine of the angle, which is 36 degrees, is equal to adjacent over hypotenuse. And now all we have to do is solve this equation. Excellent. Would someone share with me, how do I solve this? What's the first step? What do you think, Shane? What's the first step to solving this?
Multiply by 96.
Yeah, cool. Let's multiply both sides by 96. And punch this into your calculator. So we have 96 times the cosine of 36. round to the nearest 10th. So we have 77.7, and we have just found the measure of side B. And I'm going to call it yards because we know that's our unit. So we're done. Side B is 77.7 yards. Okay, let's do part B. We're told that angle B is 40. Go ahead and label that. And we're told that lowercase b is 5 inches. Where would that be located? Where would you write the 5? What do you think? Where would the 5 be located?
On the opposite side.
Of lowercase, oh, excuse me, of capital B?
Yeah.
Yes. So right across the way, if this is angle capital B, it points to side B. So side B is 5 inches. We know C is our hypotenuse, which we don't know. So this is angle C, which means here's angle A. So I'm gonna put lowercase a, lowercase c. We want to find the length of side A. So here we are at angle B. That means we need to take just a couple seconds to label hypotenuse, opposite, adjacent. We're going to label C as our hypotenuse. The side opposite angle B is our 5 inches, so this is opposite. And angle A is adjacent, or excuse me, side A is adjacent. And we want to find side A. So think about the pieces of information that you're given. Who can tell me which trig ratio, sine, cosine, or tangent that we should use in this case? Think about the information that we're given and what we need to find. What would be the most useful?
Tan.
Yes, tangent. Tangent is correct. Here's why it's tangent. We want to know length of side A, which represents the adjacent side. We are given the opposite side, which is 5 inches. So because we have these two parts to our ratio, opposite and adjacent, that instantly references tangent. So we have the tangent of 40 degrees is equal to opposite over adjacent, which is unknown. As we learned before, we're going to swap these two places. So tangent of 40 and A are going to switch. So A is equal to 5 over the tangent of 40. And then we just punch it in. Let's punch that into our calculators. 5 divided by tangent of 40. And we find that A is 5.95. 5 makes the 9 go up. So we're going to round to 6.0. All right. Go ahead and do part C. You're going to type your answer into the chat, and then we'll take a 5-minute break. I'm going to pause the video. Here we go. Let's take a look. So same thing. We know this is triangle ABC, where C is the hypotenuse. So I'm just going to label this angle C, and here's my angle A. If I know C is 90 degrees and I know angle B is 20, Well, that means angle A is 70 degrees. Keep in mind, we had to find the other angles and the other two sides. So as we kind of move through this, we can say that angle A, there's a notation that we can use for this, but I'm just gonna write angle A is 70 degrees. And then I'll switch to that notation, angle C is 90 degrees. So those are the other two angles that they were looking for. We now have to find the missing sides. Consider that you are told that side A, which is always opposite angle A, side A is 52 feet. So what we need to figure out is what are the other two sides. So I'm going to choose to start from angle B only because that was actually given to me. So if we are looking at angle B, first things first, we know that here's our hypotenuse. This side right next to angle B, that has to be adjacent. And then the side opposite angle B is obviously opposite. Okay, and we'll write lowercase b here, and we'll write lowercase c here. So we need to find both B and we need to find C. Again, I'm going to write the trig ratios up top. So, ka, toa. What I'm given here is adjacent. I need to find both the hypotenuse and I need to find the opposite side. So I'm going to write two equations. I'm going to start with trying to solve for the opposite side given adjacent. So opposite adjacent, that refers to tangent. So we're going to start with tangent of 20 degrees is equal to opposite over adjacent, which is B over 52. In order to solve this, we're going to multiply both sides by 52. So if I multiply both sides by 52, here's our original equation. We're going to multiply by 52. We know that the 52s will cancel. And let's punch into our calculators 52 times a tangent of 20 degrees. That's going to give me 18.9. We are solving for side B and our units are in terms of feet. So this is going to be 18.9 feet. And I'm actually going to write that here. So side B is 18.9 feet. The next thing I have to do is solve for the hypotenuse. So again, I know my adjacent side. I'm missing the hypotenuse. A over H, that pertains to cosine. So we have the cosine of 20 degrees is equal to adjacent 52 over the hypotenuse, which is C. These are going to trade places. So we have C is equal to 52 over cosine of 20 degrees. And now we just have to punch that in. 52 divided by cosine of 20 degrees. And we get 55.3. So side C is 55.3 feet.
Couldn't you just also find side C if you did like A squared plus B squared together?
Absolutely. Absolutely. Yeah, and then Jimmy, that's a good point because really then it just depends on your style. Like if you knew this was 18.9 and you knew this was 52, you might just be like, you know what, I'm just going to do Pythagorean theorem and find that guy. It will work. You'll get the exact same answer. Or if you like trigonometry, you just use that instead. But yeah, you'll get the same answer either way. Excellent point. Thank you for bringing that up. Beautiful. Questions? Shane?
I got 116 for B.
116 for B.
Yeah.
Try that one more time. So just punch in 52 times the tangent of 20. You should get 18.9.
No, I got 116.
Yes. Let me see. Oh, you're using your cell phone. Okay. So here's what you're going to do. You're going to type in 20, then press tangent. Oh, that's weird. Type in 20, then press tangent, then times 52.
I'm using an emulator of the TI-84.
then there's a notation that's preventing your answer. We'll look at that in the next 5 minutes. I'll see you guys at 10:25. I'm gonna pause the recording. Okay, so let's pick up where we left off. We're gonna turn to page 26. Let's take a look. Applications using trigonometric functions. Cool. So one of the biggest things that you should consider when doing these on your own, especially if you're looking at lumen problems, you're welcome, James, is draw a diagram. If they don't give you a if they don't give you a diagram, please label it. That's going to be your strategy for success. So for these, I actually have given you the diagrams, but for the future, for problems that don't, please do it. Okay, let's take a look at these. So a 550-foot rope is stretched from the top of a vertical pole to a point on the ground some distance away from the base of the pole. So we know that here is our pole, right? There it is. We have a 550-foot rope. It's stretched from the top of the vertical pole to a point on the ground. So I'm going to note that this is 550 feet. The rope makes an angle of 38 degrees with the ground. So here's the rope, here's the ground. It makes an angle of 38 degrees with the ground. How far away from the base of the pole is the end of the rope? So we want to know how far away from the base of the pole is the end of the rope. So we want to figure out that length. Given this information, we recognize that, okay, we're looking at a right triangle and we have this angle. So we're going to go ahead and label what's our hypotenuse. That's here. Which side is opposite? That's the height of the pole. And which side is adjacent? That represents the distance from the pole to the rope where it was tied to the ground. Because we are given the hypotenuse and we are looking for the adjacent side, immediately we think about our trig ratio cosine, right? All we have to do is sift through and decide which one gives us the ratio that pertains to adjacent and hypotenuse, and that's cosine. So we go ahead and we write cosine of 38 degrees is equal to adjacent side over a hypotenuse. So that's x over 550. You're going to go ahead and multiply both sides by 550. And then all we have to do is punch that in. So 550 degrees times the cosine of 38. Wow, 550 times the cosine of 38 degrees. And that's going to be x is equal to, and let's round to the nearest tenth. So 433.4 feet. And there's your answer. That's essentially how all of these trig application problems are. You have your visual, you label your sides, you figure out which trig function you're going to use, and then you apply it.
I think the part that I get mixed up with is the figuring out
Like your sides?
which trig
Oh,
thing
which
to use.
okay. So here's my advice. Think about the information you have. So what I would do if I were you, I would say, I know the hypotenuse and I'm looking for the adjacent side. The second you identify that you have these two pieces in your trig ratio, that's when you say, okay, it can't be sine, but it's got to be cosine because that deals with adjacent and hypotenuse.
Mm,
Always do that.
okay.
That's going to be insanely helpful. And actually, I'll use a highlighter again for this second problem for part B. Let me show you. A kite is flying at the end of a 200-yard string. Wow. A kite is flying at the end of a 200-yard straight string. Okay. 200-yard straight string. There it is. If the string makes an angle of 68 degrees with the level of the ground, here's the 68 degrees. How high to the nearest yard is the kite? So we want to figure out how high above the ground is this kite. So I'm going to call that Y. Just use a different letter. It doesn't really matter. So here I am at this angle. And again, the first thing I want to do is I want to label my sides: hypotenuse, opposite, adjacent. So here I'm going to label my hypotenuse. We notice that Y is opposite our angle. And the ground here represents the adjacent side. I'm going to circle the piece of information that we're given. We are told the hypotenuse. And what I need to find is the height of the kite. So I notice that I am referencing my opposite side. So once I figure out that these are the two pieces that pertain to my trigonometric ratio, I go back to my trig ratios and I say, well, the one that deals with opposite and hypotenuse, that's sine. So now I can say sine of the angle, which is 68 degrees. It's always sine, cosine, or tangent of the angle. And that's equal to the opposite side, which is y, over the hypotenuse, which is 200. Perfect. Now that I have my equation set up, I multiply both sides by 200. And let's punch this in. So y is equal to 200 times the sine of 68. And we get 185.4. And we see that it's yards. So 185.4 yards, and you're done. Good. Tiana, is that helping kind of identifying what the sides are and then the pieces that we actually need?
Yes, thank you very much.
You're welcome.
Mm.
I always love talking about that because whatever strategies and tricks we can use, everybody will benefit from. So it's really, really, really important for all of you to share those ideas and those things that you're thinking about so that it can make this class so much stronger. So thank you. A plane is climbing at an angle of 11 degrees with the ground, okay? 11 degrees with the ground. Find to the nearest foot the horizontal ground distance. The horizontal, right? Horizontal is like so. The horizontal ground distance the plane has traveled when it has attained an altitude of 400 feet. So we see that the altitude of the plane is 400 feet. What we want to figure out is what's the horizontal ground distance. So I'm going to call this Z. Again, just to use a different letter. Go through the same motions of labeling all your sides. So we have our hypotenuse, we have our opposite side, and we have our adjacent side. The next thing I'll do is I'll circle the two pieces that I need to use. So I definitely need to use the opposite side because I actually have the 400. And I'm trying to figure out what is the horizontal ground distance. So I'm going to be using adjacent as well. So because we're looking at opposite and adjacent, that pertains to tangent. Yes. So we have tangent of 11 degrees is equal to 400, which is opposite, over adjacent, which is Z. What was the trick we can use in this case? What's the little shortcut, that little mini baby shortcut?
Switch the tan 11 and the Z.
Yeah, score. Switch these two places. It's a shortcut. You don't have to do it if you don't want to. You can actually multiply by Z and then divide by tangent of 11, but you get the exact same result if you just switch them. So we have 400 over the tangent of 11 degrees, and now just punch this in. 400 divided by tangent of 11 degrees, and you should get that Z is equal to 2057.8. Good, 0.8 feet. Good. By the way, this previous one, part B, our answer should actually be to the nearest yard. So I'm going to say 185 yards. That's the answer. I want to be careful that we rounds to the nearest yard in this case. And then for this one, it says find to the nearest foot. So my answer is actually going to be 2,058 feet. We'll round up to the nearest foot. Good, much better, much better, much better. Super cool. A loading platform is 1.2 meters above the ground. So immediately I noticed that this loading platform is 1.2 meters above the ground. So essentially this is 1.2 meters and so is this one. Just to kind of identify that that's the height of this platform, right? How long must the ramp be? We'll call this C, in order to make an angle of 22 degrees with the ground. Good. Take a couple minutes and solve this application problem. You got. So we notice that obviously the C here is going to be our hypotenuse. And if you want, you could draw your 90-degree angle right there. The ground part for this triangle, that's going to be our adjacent side, which means the 1.2 is our opposite side. So we want to find the hypotenuse, right? We want to figure out how long the ramp has to be. So we need to figure out the hypotenuse, but we have the side that's opposite. So immediately we think, well, opposite and hypotenuse, that pertains to sine. So we have the sine of 22 degrees is equal to opposite over hypotenuse, right? The so in SOHCAHTOA. We're going to switch the sine of 22 with the C. And then once we punch that into our calculators, you'll find that C is 3.2 meters. And that's how long the ramp must be in order to make an angle of 22 degrees with the ground. Very, very nice. As always, if you have any questions, don't hesitate to ask. But besides that, let's turn the page unless you have a question. Okay. We're now ready to find the angle itself. So this part is actually really, really easy. You just punch it into your calculator. Like you have to let your calculator do it for you, right? So for instance, let's look at this first equation. We have sine of A is equal to 0.8790. Now let me show you something very interesting about this calculator. Do you see how I have the sine key? And then above it, I have sine inverse, right? This is sine to the -1. That means the inverse of sine. They are the same key because they're opposites. Just like you remember when we had an x squared, expression, the opposite of something squared is to take the square root, right? Or the opposite of square root is to square it. They're the same key for that very reason, right? Whoever created the calculator was, trying to be as smart as possible. So what we'll want to do here in this case, in order to release our angle, to figure out what our angle is, all we have to do is take the inverse operation. We'll do the opposite. So what you're going to do is you're going to take the sine inverse of both sides. So watch carefully what happens. The sine inverse and the sine, they cancel each other out, leaving you with just A, just our angle A. So what we'll do now is we'll take the sine inverse and I press second sine. And then I'm going to type in 0.8790. I want the sine inverse of 0.87990. Press enter, and we just found angle A, 61.5 degrees. Same thing with part B. The opposite of cosine is cos inverse. So you're going to take the cos inverse of both sides. So cos inverse, that's a cos to the -1 power, right? That's what it looks like. So cos inverse of both sides. Cos inverse and cos cancel each other out. So let's do second cosine. And that says 0.9876. And we get that the angle is 9.0 degrees. Do the last one. Can somebody type this in and then share with me what you get for angle A? So the nearest 10, what's angle A? What'd you get? You guys have calculators, I'm sure.
.3
Yeah.
degree.
Beautiful. 87.3 degrees. Perfect. Take tan inverse of both sides. Tan inverse of both sides. And you've just released A. So now you know A is 87.3. Perfect. Very nice, Jose. Thank you. So having this information will allow us to solve even more parts of the right triangle. Check out this one. Given a right triangle ABC, having side C as a hypotenuse. So the first thing I'm going to do is this. I'm going to draw my triangle, as you should as well. And my hypotenuse is C. So here's angle A, here's angle B. We are told that, and we want to give our answers to the nearest 10. So we're told legs A and B are 5 and 7. So leg A is 5 and leg B is 7. So we would like to find the other two angles, and we want to find the other side. So let's start with wanting to find angle A. Okay, so that's what I would like to find first. I want to decide what is angle A. So because I'm starting here at angle A, I want to label all of my sides: hypotenuse, opposite, adjacent. So hypotenuse, we have opposite here, and we have adjacent. Think about the pieces of information that we do have. We have the side that's opposite, and we have the side that's adjacent. As always, write your trig ratios. So ka, toa, so that we can figure out which one we would use. In this case, because I have opposite and adjacent, I'm going to use tangent. So it's tangent of angle A, which I don't know the measure of angle A, and that's not a big deal, is equal to opposite over adjacent, or 5/7. Well, we learned that in order to get A by itself, we simply have to do the opposite operation. So if I have tangent of A, the opposite operation is to take the tan inverse of the tangent of A and the tan inverse of 5/7. So taking the inverse of tangent on both sides, take a look at how we would punch this in. So second tangent, and we could literally type in 5 divided by 7. Press enter, and we get that A is 35.5 degrees. So I'm going to write angle A is 35.5 degrees. The great thing is automatically I know angle B. So C is 90 degrees, A is 35.5. So to figure out what's left, you subtract from 180, and you see that angle B has to be 54.5 degrees. The last thing we want to know is what is side C? We can do this by using the Pythagorean theorem, 7 squared plus 5 squared equals c squared, and then solving. Or I could use a trig ratio. I know that angle A is 35.5 degrees. So if I wanted to, I can look at opposite and hypotenuse. So I can say, well, let's solve using our trig ratio. So sine of 35.5 is equal to opposite over hypotenuse. That's 5/c. Switch these two, will give us the measure of side C. So 5 divided by sine of 35.5. So side C is 8.6 units, whatever our units are. In this case, we weren't given them. So we'll write 8.6, and that concludes the problem. What questions do you have for me on part A? Okay. Very nice. I'm gonna let you all play around with part B. When I scan the notes, I'll actually have the solution here. But for now, let's turn the page just so we can finish our concepts for our trigonometry supplement. The last thing we have to talk about is angle of elevation and angle of depression. So when you think of angle of elevation, think about looking up at an object. And then angle of depression, think about looking down at an object. That's essentially what's happening here. And understanding this angle of elevation versus angle of depression will help us to actually draw our diagram and understand what's happening. So let me show you part A. The Washington Monument is 555 feet high. So we know that this height here is 555 feet high. That's what it is. If a marker on the ground is 700 feet away from the top of the monument, so a marker on the ground is 700 feet away from the top of the monument. So let's draw this dotted line. And this is 700 feet away from the top of the monument. What is the angle of elevation from the marker to the top of the monument? We want to know what is the angle here. That's what we're looking for. Okay, so just having that information is exactly what you need in order to solve this problem. We go through the motion. We have our hypotenuse. We know this side is opposite. Opposite and hypotenuse that deals with sine. So it's sine of angle M is equal to opposite over hypotenuse. And we know in order to solve for that angle, we're going to take the sine inverse of both sides. And M is equal to, let's do sine inverse of 555 divided by 700. So the angle of elevation, round to the nearest degree, is 52 degrees. And that's your answer. Okay. Beautiful. I'm going to set up part B for you, but the rest of the problems are essentially exactly identical. And then that concludes our notes. So a 25-meter high flagpole, 25 meters high, casts a shadow that's 10 meters long. The shadow would be on the ground, right? So cast a shadow that's 10 meters long. Find the angle of elevation from the ground to the sun to the nearest 1/10 of a degree. So we want to find the angle of elevation. We're essentially looking up towards the sun. You can just envision that the sun is here, which is why it casts a shadow, okay? So we want to find the angle of elevation from the ground to the sun to the nearest 1/10 of a degree. Do the same thing, label your sides, hypotenuse, opposite, adjacent. We only are focused on our opposite and adjacent sides, which means we're going to use tangent. We want to know the measure of angle A. So we have tangent of A is equal to opposite over adjacent. Use tan inverse of both sides to help you find angle A. So tan inverse of 25 divided by 10, that's going to give me an angle of, and we want to the nearest 1/10 of a degree. So this is 68.2 degrees. And you're done. Thank you all so much for, staying a couple extra minutes so that I can finish part B. There are only a few problems left. I will be writing up the solutions for that, and I will scan my notes and send those to you today. But I do want to say excellent work. Thanks for sticking with me. We finished the course. We finished all of the content and you are ready to kick butt and just complete all your work. Okay. I'm here for you.
Yeah.
If you need help, please don't hesitate to reach out. Jimmy.
One, I'm just gonna say yay. God.
Yes.
We'll
Big
get
time.
there. Yeah. Just thank you for being a great teacher. So
Thank you.
yeah, I appreciate the last 2 semesters of being with you.
Yeah,
So
that's
thank you.
right.
I've learned a
Back to
lot.
back. I'm so glad you
Um,
actually attempted it with me because I know that you were a little
Mhm.
bit concerned and I was like, just try it, like I think you're gonna
Yeah.
be successful and you are. So that's really, really awesome, Jimmy.
Thanks. Also, Nan, do you know anything about the next course up,
Yeah,
like 165?
165, yeah.
Do you know what the majority of that is going to be of?
It's a lot of content, like a lot of content.
Yeah.
I mean, I would never take 165 in a 5-week course. Never. That'll never happen. It's not a good idea. So if for all of you taking 165, take it in the fall if you can, while this material is still fresh.
That's what I'm doing.
Okay.
Good.
Are
Good.
you teaching 160?
I am teaching, I'm not teaching 160 this fall. But you probably will want to take college algebra next. So you should take 165 next, and that's for all of you. So once you pass this class, please take 165 next. It's not a good idea to wait a semester because then you'll lose some of this material and you'll be like, oh crap, I forgot what we covered in 104. It always happens that way. So the sooner you take it,
Gotcha.
the better you'll be.
Okay.
All right.
All right. Thank
And as
you.
always, I do want to tell you
Mhm.
all, I'm here for you. So even after this semester, let's say you're taking your math class with somebody else next semester, you need help, come see me. Just shoot me an email.
Thank
We'll set
you.
up a time. You're very welcome.
Thank you so much.
Awesome.
You're
Thank
welcome.
you.
Good
you.
luck.
Mm-hmm. You too.
I had a question.
Yeah, Tiana, what's up?
You were mentioning something in the beginning of class about Saturday.
Yeah, I extended the due dates of units 3, 4, and 5, including the final exam, everything to Saturday by 11:59 p.m. I pushed all the due dates.
Okay, thank you.
You're very welcome. Bye, everyone.
See you guys later.
Bye. Have a
Bye.
nice day.
Bye. Have a nice summer.
You too.